Hello and welcome to this learning session on the Moore Industries SPA2 configuration software. And in this learning session we are focusing on the high-level SPA2, high-level meaning it takes a voltage or current input as opposed to a temperature input on the low-level instrument. And the tab we'll be discussing today, we'll be focusing on, will be the analog output tab. Let's jump over there right now. You can see how I'm currently set up. But let me hit the stop button, so if I make any changes, the software must be stopped. Can't be monitoring the instrument while I'm making changes. Okay, let's take it from the top here. There's basically two modes of operation for the analog output. You can either have a current or milliamp output or a voltage output. The process variable range that I've defined for my input is 4 to 20 milliamps in my case here. And right now I have the output range to equal that 4 to 20 milliamps. I can also make it slightly different if I wanted a 0 to 20 milliamp output, and that will scale the 4 to 20 to be 0 to 20. And that depends on your application. But I'll leave this one at 4 milliamps, so it's 4 to 20 milliamp output. This is the most common use of that. Okay, and down below here we have a feature called damping, and you can enable that and then enter a value in here which will be from 0 to 30 seconds, 30 being the highest. I'll show you, I'll demonstrate that in a moment, but let's just go down to the fail mode. The fail mode is you're basically telling the instrument what you want the output to do in case of say the input fails. There's no more input coming in at all. You can have it fail high, which will go to 23.6 milliamps, or fail low, which will go to 3.6 milliamps upon failure. Okay, and also up here you have a window that's very helpful. It tells you what your output current is, or your voltage if you're running on voltage. It tells you what your output is currently set at. And if you notice when I shut it off here, I had 12.002 milliamps coming into the instrument and 12.002 milliamps going out. So it's just taking the input and basically echoing it at the output. So let's go back and talk about the damping. Now normally, and let me start it up again here so we can see how the output reacts to a change in input. Okay, we'll wait for it to get running. There we go. We have 12, just a little over 12 milliamps coming in, the same thing going out. Now I'm going to jump the output up to 20 milliamp input, and there it goes. It jumped up there and jumped up there. So, and I'll go back down to mid-range, which would be 12 milliamps, and there it goes, 12 milliamps there, 12 milliamps there. And we'll stop it for a moment. Now, if you want to see what damping does, we'll enable the damping, and then we'll set it up to a number, let's arbitrary number just for demonstration purposes. I'll set it to 10 seconds. I'll do a quick set so that change will now be downloaded to the instrument. Okay, we'll start the instrument back up. We'll wait for it to update here. We'll notice that by the progress bar here. There it is. Okay, so we still have 20 milliamps going in, 12 milliamps going in, 12 milliamps going out. Now I'm going to jump it up in one push of a button up to 20 milliamp input. We'll see that over here. And then what we want to look at after that is the change in the output with the damping enabled. So here we go, changing the input. There it goes up to 18 and 20 milliamps. Now look at the output. The output is slowly moving up because it's dampened. It's going to take 10 seconds to get the output to 60% of the change. And then it'll slowly trickle up to 100% after that. So, and where is that good? That's good if you have an application where the input is very, jumping around quite a bit. It's not a smooth transition, and you don't want the output to be jumping around, but you want it to get there eventually. And you can see it's climbing up to 20 milliamp signal now. Of course, 10 seconds might be a little large of a dampening figure. You may want it a little smaller than that. It's totally up to you. I put 10 seconds in there just for demonstration purposes. Now, before I get too far along here, I do want to stop that and disable the damping, because I don't need it for my rest of my demonstration here. There. And, of course, if I start it back up, you'll see this will pop right up to 20 milliamps, the same as the input, because there's no longer any dampening. Before they take a reading, there we go. 19.999, close enough for government work. Okay, now, and we can also discuss these over here, which are good for maintenance purposes. You have a trimming function and an output test function. Let's do the output test function. That's a little easier to understand. You can put any number in there. Hit the stop button. You can put any number in there that you like. Say like 12 milliamps, and you can say fix. And what that will do, that will send an output of 12 milliamps to your DCS or wherever you have that's taking the reading of the output of the SPA2. And you can determine if all your wiring is correct, you should be receiving that 12 milliamps at your DCS. Now, I'll say unfix, you don't want to leave it there. Trimming is somewhat similar, but what it allows you to do is go to your entire span. You can say you can fix it at the lower and the upper range one at a time. When you fix it at the lower range, by example, we'll go through it here. If it goes to your DCS and the lower range here is 4 milliamps, so if it goes to your DCS and their reading, say 3.8 milliamps due to some variance in wiring or whatever, or their meters off, whatever, then you would come down here and you would say, okay, I'm only reading 3.8, and then you would say trim. And that will trim the amplifier in the SPA2 so that now it'll match the lower output. 4 milliamps will be matched on your DCS. And you can do the same thing with the upper. You can tell it, okay, it's 20 milliamps is going out, and my DCS is reading 19.9, and say trim, and that'll adjust the SPA2 to match your DCS. Of course, when you're done with all this, before you go back to operation, make sure you hit the unfix button, or it's going to be putting out a steady 20 milliamps. And if you're unsure that you did it right, then here's your bailout button right here. You can just say reset, and that will set the analog output trimming back to the original factory defaults. Okay, so that's it for the analog output tab. Hope everything is clear there. You can always play around with it a little bit. You won't hurt anything, as long as it's not connected to your application. And remember, anytime you're monitoring, you have to hit the stop button before you make any changes, and then make sure you do a download of the configuration. Anything that you've done, you can do a quick set. That'll download just the one page, or if you hit this down arrow, that will download all the changes you made, even if they were on other pages. I'm just doing that to be sure I got everything. There we go. And thank you for listening.